Sorry we got cut off so abruptly in the last video. The recorder I'm using only lets me have 15 minutes, and sometimes I forget to watch the time. We were in the middle of part C at the top of page 3, and I was about to pull out the calculator. So here it is, and we are doing 1 minus, in parentheses, 0.03, and this time we were going to try with 4 components. So make a 4 for the exponent. And we have 1, 2, 3, 4, 5, 6 nines, and then a 1 9. So that gives us 0.1234. But remember, we need 8 nines. So 4 components is not enough. All right, so let's try 5 components. So it's the same thing, but we're going to raise it to the 5th power because we have 5 components this time. And that gives us 0.999999998. So this is only 7 nines and then an 8, and we needed 8 nines. So 5 components is also not enough. So now let's try 6 components. So the same formula, it's just raised to the 6th power. And if we put that one in the calculator, well, let's try it. So get my calculator up, I will clear that, and I will clear the screen. So 1 minus 0.03 raised to the 6th power. Okay. We now have 9 nines followed by a 3. So, one, 2, 3, 4, 5, 6, 7, 8. Let me make sure I counted those right. 1, 2, 3, 4, 5, 6, 7. Yep, that's definitely 9 nines. 993. So that's finally larger than what they wanted us to get to. So the system should have 6 components. All right, now we need to talk about at least probabilities. So at least means greater than or equal to. For example, in most of the United States, you have to be at least 21 to drink alcohol, right? That means you have to be greater than or equal to the age of 21 before you're allowed to legally consume alcohol. So the probability of at least one of something is 1 minus the probability of none of that thing. That's the way the complement works for that. So for example, among 21 to 25-year-olds, 29% say they've driven while under the influence of alcohol. Suppose 3 21 to 25-year-olds are selected at random. Compute the following probabilities. What's the probability that all 3 have driven while under the influence of alcohol? So the probability of 3, and I'm just going to write drunk instead of driving under the influence of alcohol, is the probability that the first is drunk plus the probability, that's not plus, and, my mistake, and that the second person was drunk, and the third was drunk. Okay, and we remember, since whether or not I'm drunk has no bearing on whether or not you're drunk, assuming hopefully you're of legal drinking age, we just multiply all the probabilities together. So since 29% of them say they've driven while under the influence of alcohol, we have to change the percent into a decimal. So that's 0.29. So we have 0.29 times itself. So the probability that all 3 of them have driven under the influence, let's get our calculator out. And remember, we can use an exponent since all those numbers are the same, and since there's 3 of them, we use a 3. So we get 0.024389. So 0.024389. Okay, just checking I had the decimal point in the right spot. So that's the probability that all 3 of them, if we pick random people, have, well, 21 to 25-year-olds, randomly, that have driven, that all 3 of them have driven under the influence. So what's the probability that at least one has not driven while under the influence? That is 1 minus the probability that none have driven under the influence. The probability that at least one has not driven while under the influence is the probability, 1 minus the probability that none have not driven under the influence. So I know that sounds crazy, and in normal English we don't usually say none have not done something, because that's kind of odd to our ears in English. But if none of them have not driven drunk, that means all of them have driven drunk. that's the probability we just calculated. So we do 1 minus 0.024389. And that gives us, if I just round off that probability, 1 minus 0.024, we get 0.976 for the probability that at least one of them did not drive drunk. I know that's a little contorted, and I know that the English is a little bit strange sounding, but that's how that works. So if you think about the English part logically, then you can work that towards math. Okay, moving on to the next part, which is the last problem. What's the probability that the first two drove under the influence and the third did not? So that's the probability that first was, I'll just write DUI, and the second was DUI, and, and the third was not DUI. So that's the probability that the first was DUI. Remember, these are independent, times the probability that the second was DUI, times the probability that the third was not DUI. So remember, the probability that we pick one person at random and they were driving under the influence of alcohol is 0.29. So that's the probability for the first one. The probability for the second one, driving under the influence, is the same thing. The third one was not DUI. So this one, that's a complement, so it's 1 minus the probability that the third one was DUI. So we can just substitute in there, that's 1 minus 0.29. And we just put all that in the calculator, so here we go. And clear all this out. We have 0.29 times 0.29 times 1 minus 0.29. And all three of those should be in parentheses, just like the way I typed them in. And when we hit enter, we get 0.059711. So 0.05, and we'll just leave it at 97. That is all for section 5.3. I just want to remind you that if you need any help with any of this math or anything else, please do not hesitate to contact me. And if my listed office hours do not work for you, please remember that I am more than happy to make arrangements with you at any time that's convenient for you, as long as I'm not teaching. I will see you guys in section 5.4.